Hey everyone, welcome back. Today we're going to continue our lesson on linear equations. We're going to write an equation, then we're going to graph some equations, and then we are going to interpret a graph. Okay, so here, the graph here models the cost of joining a gym. We're going to write an equation of the line explaining the meaning of the slope and the y-intercept of the line. Okay, so we will start with our equation. So I need a slope, m equals, and then I've got y minus y, 363 minus 231 over 5 minus 2. Now what these numbers mean is that after 2 months, you've spent $231 on this gym membership. After 5 months, you've spent $363. Okay, so we're going to find a slope, and that's going to help us calculate the monthly cost of this gym. Okay, so the slope is 363 minus 231, which is 132, over 5 minus 2, which is 3, and let's see if that simplifies. So divided by 3, it's 44. So the slope is 44. Okay, so I can pick one of these points to help me write an equation. I'm going to pick the smaller one, and that will be my x1, y1. So in point slope form, I've got y minus y1 equals m times x minus x1. Now I'll distribute. Y minus 231 equals 44x minus 88. And then I'll add 231. So I have negative 88 plus 231, and that is 143. So y equals 44x plus 143. That is the equation of the line. So it says write an equation of the line. Check. I've done that. Now explain the meaning of the slope and the y-intercept. So here's the slope. It's 44. Okay, so the slope is the monthly cost. Okay, so it costs me $44 per month to be a member of this gym. Okay, explain the meaning of the slope. Check. And the y-intercept. So the y-intercept is how much it costs to start. So it's your initial cost. Initial cost to join. Okay, so you go to this particular gym and say, I want to join. They say, that's great. I need $143. And then after that, it's $44 per month. Okay, so it costs you $143 to join, and then it costs you $44 per month at this particular gym. All right, next up we are going to graph some lines. Okay, so there's a couple different ways that we could graph this first one. So for this equation, I could solve for y and get it into slope-intercept form, so let's do that. So I'm going to do minus 3x on both sides, so I get 4y equals negative 3x plus 12. And then I'm going to divide every term by 4 and get y equals negative 3/4 x plus 3. Okay, so what that means is I've got 3 as a y-intercept, so I'm going to come to the y-axis here and go up 3 and plot a point. Okay, then from there I've got a slope of negative 3/4. Negative 3/4 means I can go down 3 and right 4. And I can do that again. And I want to do that as many times as will fit on the graph, and I can't fit another one that way, but to keep a negative slope, I could go, instead of down and right, I could go up and left. So up 3 and left 4. Okay, so then I connect all those dots. I want to put as many points on the graph as I can to help me keep the slope as best I can all the way through the graph. And I definitely want to put arrows on both ends because lines go infinitely in both directions. Now, I could have done it this way. Put in a 0 for x, 3 times 0 plus 4y equals 12. And 3 times 0 is 0, so that is gone. And then divide by 4, and I get y equals 3, and there's my y-intercept. Then I could find the x-intercept by doing 3x plus 4 times 0, so I set y equal to 0. So I've got 3x equals 12, and when I divide both sides by 3, I get x equals 4, and that gets me the x-intercept. From there, I still have to count down 3, right 4. I have to count that slope and then continue that slope in both directions. Okay, so two different options to do the same thing. Now, as I go to this next line, I'm going to switch colors just so it shows up nicely. So I'll do this one in blue. So I've got a y-intercept of -2. So I'm going to start here down 2. And I have a slope of -1/3. So this one's going to fall from left to right, just like the first one did. So I'm going to go down 1 and right 3. And I'm going to do that as many times as I can fit. And then, to keep that same slope, instead of going down 1 and right 3, I can go up 1 and left 3. And now I have fit as many as I can on this graph. So I'm going to connect all of my dots and put arrows on both ends. And for the last one, I'll go green. X equals 5. X equals 5. That means I start at the origin and I go right 5. And from there, I'm going to make a vertical line so that no matter what y value I'm looking at, the x value is always 5. Okay? So this equation, y equals 50x plus 125, models the total cost of joining a climbing gym. So maybe like a rock climbing place. What are the meaning of the slope and the y-intercept of the line? Okay, so the meaning of the slope. The slope means it's going to cost $50 per... Now, it doesn't say month or anything like that. Up here, it did say it was months. You can probably assume it's months. I'm just going to go ahead and assume per month. And the y-intercept tells me that it's $125 just to join. Okay, so they charge you $125 so they can do the paperwork, maybe give you a towel or a t-shirt or something. $125 to join, and then $50 per month. Okay, number 6. So I'm going to do this with the intercepts. So that's this method right here. So I'm going to say x is 0. 2 times 0 minus 3y equals 6. And this will help me find the y-intercept. 2 times 0 is 0. I'll divide by -3, so I get y equals -2. So my y-intercept here is -2. Then I'll find the x-intercept. 2x minus 3 times 0 equals 6. So 2x equals 6. And when I divide by 2, I get x equals 3. So I have an x-intercept of 3. So this goes up 2 and right 3. So I'm going to continue up 2, right 3. And when I run out of space that way, I'll go down 2 and left 3. And then I can connect all of my points. and put arrows on both ends. We always want to put as many points as we can fit and put arrows on both ends. Okay, so this time I'll do blue for y equals 4. So I'm going to count from the origin to y equals 4, and I'm going to have a horizontal line so that no matter what x value I'm looking at, my y value on this line will always be 4. And then green for this last one, where I have a y-intercept of 3 and a slope of 2/5 up to right 5. Okay, and when I run out of room going up and right, I can go down and left. Down 2, left 5. And then connect all of those points and include arrows on both ends. Okay, now we are going to interpret this graph. You can rent Blu-ray movies at a local store for $4 each, but an internet company offers a flat fee of $15 a month to stream as many movies as you want. How many do you need to stream in order to make the internet company a better deal? Okay, so if you watch a lot of movies, the internet company is definitely a better deal. But if you only get a few movies a month, then maybe you'd be better off just renting. Okay, so here are two lines. So the red represents the internet company. It's just $15. Y equals $15. This line right here is the rental store. If you rent one movie, it costs you $4. 2 movies, $8. 3 movies, $12. 4 movies, you're at $16 now. You've already spent more at the rental store than you would have if you had streamed them. Okay? So how many movies do you need to stream to make the internet company a better deal? You would stream 4 movies for $15 rather than renting 4 movies for $16. Suppose the price goes up to $16.50 for the streaming service, but the local rental is still only $4. Now how many Blu-rays do you need to rent a month to make streaming the online version a better deal? Okay, so now we can move this up to $16.50, so it's somewhere up here, and suddenly 4 movies that we rent from the local store costs less than streaming. But once we get to that 5th movie, we're now at $20, so it would be 5 movies. Okay, what if you had a 2-for-1 coupon that you could use once at the local store? Okay, so you can get 1 free movie to go with another one. Well, that just adds on 1, so you could get 6 movies for less than what you could stream 6 movies for. All right, now what if you could use that coupon every time? Then you could take that 5 movies and you could double it to 10 movies before streaming becomes a better deal.